All right. So it's good to see everybody. The plan today, we're going to go ahead and start with the quiz, the intro to logs quiz that we had a couple of days ago. After that, I'm going to go ahead and start to introduce you how to graph a logarithmic function. And then after that, we're on SEL. Now, going into next week, on Monday, we do have the homework for the log properties due. So we'll go ahead and talk about that. Then we'll have a quiz over log properties. And then we'll go ahead and continue with the log graphing. And we'll just continue that next week. Quiz on Monday. So I will, but the good news is we have that review in the form of the homework. Okay, so we'll use that. And then I will see you on Tuesday. In fact, I'll have a calendar up and ready by that time. But Tuesday afternoon will be 1 through 4. I'll see you Wednesday. That's actually the last time I'll see you next week because Thursday afternoon is a 5 through 8, and next Friday we're not even in school. Yep, there you go. You have not this weekend, but next weekend is a 4-day weekend.
Yeah, well, basically the half days. I think we only have like a total of we have the 2 half days, which is 1 day, and we have Monday and Wednesday. So really only have like a 3-day weekend.
Yeah, it's really quick. So, okay. Now let's go ahead. First off, here is the quiz that you took a couple of days ago. Were there any questions on it? Okay. Like I said, you folks did really well for logs, converting, finding the value, anything you want to take a look at. Oh, the bonus was, what was your bonus? It was Minecraft, that's right. Yeah. What? Oh, it was a carved pumpkin. It's just the rules of the logic of the game. Yeah. Every time I'm going to fight an Enderman, I don't do like a melee or anything. I make sure there's a water source nearby, and as soon as I look at him or do something, I just jump in the water, and he's like, and then you just sit there and hit him until he dies. Oh, okay. No, I never thought about that. Yeah. That's a good idea. That's a good idea. All right. Well, here we go. All I want to do is give you an introduction, and we are done. Okay, so logarithmic parent function. So this is what the parent looks like. So f of x equals log of x. Now, the base, here you're going to look at that, that's base 10. But the base can actually be either a growth or a decay. Okay. So I kind of just want to go back and review exponentials for a second. So you'll notice on each of these, I've actually got 2 grids because remember in exponential, we can either have a growth, okay? Exponentials are going to have a horizontal asymptote on the x-axis. Okay. So they're going to go ahead, if it's a growth, it's going to curve up. And now we're not talking about transformations or anything. Let's just say it's the growth or decay parent just based on whatever the value is. So it's going to go through the point 0, 1. Okay. This is if your base is greater than 1. Now, if your base is less than 1 but greater than 0, this is a decay. So very quickly it's going to get very small, but it's still going to pass through that point 1, 0. Oops. 0, 1. Not ready to switch that yet. Now, once you start transforming it, then it's no longer guaranteed to go through that point. But every exponential parent's going to do that. Now, remember, one thing we've seen about exponentials and logarithms is that they're inverses. So, for example, if exponentials have a horizontal asymptote, what kind of asymptote would a log have? They're going to have vertical, while the exponentials always start on the x-axis. The asymptote for a log will always start on the y-axis. Okay. So you can have a growth. If your base is greater than 1, you're going to start small, and you're going to curve up to the right. So this is what a growth log looks like. If it's a decay, if your base is between 1 and 0, it'll start above, and it'll curve down to the right. Now, in both cases, What's the inverse of 0, 1? 1, 0. So whether it's a growth or a decay, every log parent is going to go through the point 1, 0. Now, of course, once you start to transform it, if you, dilate it, if you go ahead and start to shift it, well, then that's no longer a guarantee. Okay. And then this, it's an older resource. It's talking about using base 10 logs, because you can do that on the calculator. But as I've already shown you in a previous lesson, we can actually use whatever base we want. Okay, now when it comes to the vertical asymptote for a log, only a horizontal shift is going to be capable of moving it. Okay, if I reflect it, if I go ahead and dilate it, none of that changes. It's always going to be the same. So we're going to do something interesting to go ahead and graph logs. We're actually going to use what we know about exponentials to help us here. So let's take a look. Let's say here are my x's, and we're going to start with the same x's. -2, -1, 0, 1, and 2, just like we did for normal exponentials. Okay. But looking at log base 2 of x, what's the base? That's the argument. 2. So the exponential inverse to this would be 2 to the x. Okay. So we're going to go ahead and graph the log by first getting points for the inverse exponential. So this is going to make sense in just a second. Let's go ahead and fill in these points. Let's start with the easy one. What's 2 squared? 4. 2 to the first? 2. Now 2 to the 0. That's 1. Now if I plug in a negative power like 2 to the -1, remember we make a negative power positive by taking the what? The reciprocal. There you go. So I go ahead and flip it. That's 1/2. So what would be 2 to the -2 power? Okay, that would be 1/4. So that's pretty easy. Okay, we got a table created using the exponential. Now what we're going to do in order to get the log, we're going to go ahead and say x log base 2 of x. Well, remember, exponentials and logs are inverses of each other. So what does that mean? What's the core idea for an inverse? Well, log is a power, true, but what do I do with the x's and the y's when I'm talking about an inverse? I switch them. So these x's right here, from the -2 all the way to 2, they're now going to be your y values. These original y values, they're now going to be your x's. All I'm going to do is take the inverse. So I'm going to invert those points. So this is 1/4. This is 1/2, 1, 2, 4. Now, because this does not have a horizontal shift, that means my asymptote is right here. Okay. And now let's plot the points and let's see what happens. Okay. Now, is this a growth or a decay base? It's a growth. The base is greater than 1, so I should expect a graph that curves up to the right. Well, let's see what happens. So 1/4 gives me a -2. So let's say right there. 1/2 gives me a -1, 1, 0. And see, there's that point, 1, 0, that we were talking about. 2, 1, and then 4, 2. 1, 2, 3, 4, 2. Okay, so if I go ahead and connect these points, see, it's curving just like we thought it would. So that's how we're going to go ahead and graph a log. Even if there's any transformations, we're going to start with the parent exponential. Then we go ahead and apply those. But we're going to start to look at that next week. Okay. Any questions? Anybody having a hard time? Okay. Well, let's go ahead and set the domain. So how wide is this? Now, it's infinitely wide for one direction, but this asymptote kind of acts like a wall. So it has to be x greater than what? 0. Now, why can't I put greater than or equal to 0? Yeah, because you can't ever touch the asymptote. The graph of the asymptote will never, ever, ever touch. They're going to get really, 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 really close, but they won't ever touch. Now, remember, this is using an inequality. If you wanted to go ahead and write it as an interval notation, you can go ahead and say everything from 0 to infinity. Remember, I want to make sure that you're still up to speed on those, because coming up, we have that post test in May where all the information from the year is going to be kind of collected. It's a cumulative test. Just in case they use a different variation, I want you to make sure you're still okay. But let's go ahead and use Y. Actually, no, let's not use Y because for this one, what's the range? Like, how tall is it? Yeah, it's just all reals. It's infinitely tall. Yeah, because exponentials and inverses are, yeah. So exponentials are always infinitely wide, so logs are always infinitely tall. Yeah. Okay. Now the end behavior, this is referring to the left and right side of your graph. So in this case, the left side is where the asymptote is. And then we have the right side. Well, it says as x is approaching blank, f of x is approaching infinity. Okay. Well, what part of this graph is actually approaching infinity? Okay. The right side. Well, you're only going to go to infinity as x approaches infinity. See, this right here, we're approaching infinity on the right side. Okay. Now, for the other one, as x approaches blank, the y values f of x are approaching negative infinity. Well, here's the only part of the graph that's going to negative infinity. So what is it going to get really, really close to? 0, but never touch. It's going to have that relationship with the asymptote. Yeah. Okay. We were able to find the x-intercept from my table. So that is 1, 0. And what's the equation of the asymptote? Oh, dot y equals x equals 0. There we go. Okay. How are we doing? Okay. All right, well, let's try one more. This will be our last one today. Now, we're going to go ahead and do the exact same thing. Is this a growth or a decay? So this is a decay log, so I would expect it to go ahead and curve down to the right. Okay, so I'm going to go ahead and graph its exponential inverse first. Because the base is 1/3, that would be the exponential parent, the inverse. Okay, we're still going to use the same x values, -2, -1, 0, 1, 2. Now let's take out the easiest ones first. Like, what's 1/3 to the 0? 1. What about 1/3 to the first? 1/3. Now, what if I took 1/3 and I squared it? Ooh, you're right about the 9. 1/9, because we apply the power. There you go. So that would be 1/9. Now let's go ahead and take care of those negatives. So if I have 1/3 to the -2, okay. Now remember, in order to make a negative power positive, we're going to take the reciprocal. So this would be 1/1/3 now to the +2. But you just told me that 1/3 squared is a 1/9. So dividing by 1/9 would be the same as multiplying by what? What's the reciprocal of 1/9? Okay. So we're looking at 9. So in fact, whoever shouted out 9 a second ago, yes, you are absolutely right. Okay. So what would happen if I say 1/3 to the -1? We go the same process. That is 3. Okay. Now remember, this is for the exponential though. If I want the log, here's my x, here's log base 1/3 of x. We're going to take these points, and we're just going to switch them. We're going to take the inverse. So -2, -1, 0, 1, 2, and then this would be 9, 3, 1, 1/3, and then 1/9. So let's see if we actually do get the decay we were talking about. So here's my asymptote. Let me go ahead and do this in a different color. Let's say red will stand out. So we have 9, -2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, -2. Then we have 3, -1. Then we have 1, 0. Then we have 1/3, 1. And then let's say 1/9, 2. So right about there. Okay. So if I go ahead and connect that with a smooth curve. Okay. It is the type of graph we thought we should get. Okay. So what's the domain? Okay. All x greater than 0. Okay, what's the range? All reals, it's infinitely tall. All reals. Okay. Now we're filling in the blanks here. As x approaches blank, f of x and y's are going to approach infinity. So let's see if you can go ahead and fill these in. So you're looking at the graph. One of these represents the left, one of these represents the right. So if the y values are approaching infinity, there's only one part that's approaching infinity. As the f of x values are approaching negative infinity, there's only one part that's approaching negative infinity. Okay, so write in what you think is going to complete these statements. Everybody think they're ready? No? Okay. Okay. So if we want the part of the graph to go to infinity, the only part that's going to infinity is this one, and it does so by getting closer to the asymptote 0. Okay. If I want the y values of the graph to go to negative infinity, which is this portion right here, the only way that's going to happen is as x gets larger itself. The further right I go, the further down the graph goes. Okay. How many people got those? Okay. Those are a little tough in the beginning with logs, but we'll go ahead and practice them. We'll talk about them. We'll make sure you feel pretty good about it. What was the x-intercept? Again, just like we talked at the top of the lesson, it is 1, 0. We got that from my table. And then the asymptote is x equals 0. There we go. And then when we come in after we do our quiz and review on Monday, we'll go ahead and start looking at a few of these where we have transformations. Okay. All right. We are done.